So chemical properties of the haloarenes. The next concept what we are going to be discussing means here. So we'll discuss about here chemical properties of haloarenes. Haloarenes. Okay. So in last class we had seen so preparation and chemical properties of the haloalkanes also we completed. So next we are going to discuss about here chemical properties of the haloarenes. So before going to the chemical properties of the haloarenes, now my question is, if you compare with the haloalkanes, compare with haloalkanes and haloarenes So which one are more reactive? If you compare with the haloalkanes and haloarenes, which are more reactive? Ritu? In haloalkanes and haloarenes. So which are more reactive? If it is reactive means why it is more reactive? That is my question.
Sir, I think haloarenes is less reactive because of the order of reactivity.
Order of reactivity is any other reason? But simple logic, let's see. So to me, I'll make it clear here. So whatever you told that correct only, but it's not the reactivity order. Practically, we can see here in haloalkanes. So in haloalkanes means here halogens are attached to the sp3 hybridized carbon atom only. Na? So this is one. So what is the hybridization of the carbon means? It is sp3 hybridized carbon atom. Is it right? And in chlorobenzene, we can check it out. In chlorobenzene, wherever the chlorine is going to be attached, that carbon is having sp2 hybridization. Okay, so that chlorine in that carbon is having sp2 hybridization. Now my question is, if you compare with the haloalkanes and haloarenes, which are more reactive? Okay, so which are more reactive means haloalkanes are more reactive than that of the haloarenes. Okay, haloalkanes are more reactive than that of the haloarenes. So why the haloalkanes are more reactive means in this one, the halogen attached carbon is exhibit as a sp3 hybridization. That time it has a greater the bond length between the carbon and chlorine. Okay, so bond length it will be more. And if you compare with the haloarenes in between the carbon and chlorine, so bond length it will be less. Okay, so what is the relationship between the bond length and bond energy? Bond length and bond energy are the inversely proportional. Na? Okay, bond length and bond energy are inversely proportional. Okay, bond length and bond energy are inversely proportional. So that means for which one it is more energy is required to break the bond? Either haloarenes or haloalkanes? Which one is required more? Haloarenes are required more energy to break the bond. Okay, so because of it exhibit as sp2 hybridization. So what happens if the sp2 hybridization? If the sp2 hybridization is percentage of S character is going to be increases means electronegativity is going to be increases. If the electronegativity is going to be increases means bond length is going to be decreases. Okay.
Sir, so electronegativity.
Electronegativity is going to be?
No, sir. I thought it was sp3. sp3 as sp. Instead of sp3, I thought it was sp.
sp2 here. We have a sp2. Okay, sp3, sp2, sp. If you compare with the sp2 and sp means sp is having the greater the electron negativity. Percentage of S character is going to be increases means electron negativity also is going to be increases. Now we got the clarity here. Okay, next. So what is the another reason we can say means here? So what is the second reason why the haloarenes are less reactive towards to the less reactive means here because of haloarenes. Okay, that means whatever the halogens are there on benzene ring, they undergoes to the resonance. When they undergoes to the resonance means they form as a partial double bond between the chlorine and carbon. So when it forms as a partial double bond means more energy is required to break the bond. So due to that reason only, haloarene is also less reactive, okay, towards to the nucleophilic substitution reaction. Clear? So haloalkanes are more reactive towards to the nucleophilic substitution reaction while comparing with the haloarenes. Now you got the clarity. I'm giving the clear statement. Where we are seeing means here, haloalkanes are more reactive towards the nucleophilic substitution reaction. Towards to the nucleophilic substitution reaction. Nucleophilic substitution reaction. Substitution reaction. And reactivity also. Reactivity also clearly we can explain. So why the haloarenes are less reactive towards the nucleophilic substitution reaction here? Because of when the halogen are it undergoes to the resonance. What is meant by the resonance? What is meant by the resonance, ma?
Shifting of pi bonds?
Delocalization of the pi electrons. A delocalization of the pi bond is called as a resonance. Okay. Now, if we see benzene ring means total how many pi bonds are there? We have a 3 pi bond. And chlorine atom, how many electrons are there? Means we have a 6 electrons, ma. Okay. We have a 6 electrons. When the chlorine is donates the electrons to this carbon atom, this carbon it will has a more electron dense. Then it shifts this pi electrons to on this carbon atom. When these pi electrons are shifted on the second position, this carbon get as a positive charge. This carbon get as a positive charge. And positively charged carbon atom is it forms as a double bond with the chlorine atom. Positively charged carbon atom is it forms double bond with the chlorine atom. Sir, how it forms as a double bond means because of chlorine is donating to the electron. If it donates the electrons means it forms as a double bond between the chlorine and carbon. And this carbon get as a negative charge. This carbon get as a negative charge. So based on the resonance only, we are going to be explain the electrophilic substitution reaction. So, okay. So what is going to be the electrophile, which we can call as electrophiles, ma? So what is going to be the electrophile? What is going to be the electrophile?
So electron-loving species.
Electron-loving species, electron deficient molecules. Electron deficient molecules also we can call as here electrophiles here. Now let us see in this one. So in second structure, first when the pi electrons are delocalized means you got as a one structure. Again, when this pi bond is shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. And the double bond is formed between the positively charged carbon atom and negatively charged carbon atom. Then it forms as a new resonance structure. Okay, here you will get as negative charge and double bond, double bond, double bond, Cl plus. Again, when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge and this carbon get as a positive charge. Okay, again in between the positively charged carbon atom and negatively charged carbon atom, it forms as a new bond here. Okay, here one more bond. Here we are having negative charge. Again, double bond Cl plus it is there. So again, this carbon is donating the 2 electrons to the chlorine atom. If it is donates the 2 electrons to the chlorine atom, means again this carbon get as a positive charge. Again, it forms one more bond in between the positively charged carbon atom and negatively charged carbon atom. So now finally you will get as a neutral molecule. So when the pi electrons are, it undergoes to the delocalization. Total how many resonance structures we got, ma? Total we got as here 5 resonance structure. In all the resonance structure, if you see means in between the chlorine and carbon, we have a partial double bond. Okay. To cleave that partial double bond, more energy is required or less energy is required, ma? More energy is required or less energy is required? Which bond is easily we can break? Either single bond or double bond?
Double bond.
Which bond is easily breaks, ma?
Single bond.
Single bond or double bond? Single bond is
Single
easily
bond.
breaks. Okay. Carbon, single bond carbon is easily we can break smile. Okay, the number of bonds are increases in between the atoms means more energy is required to break the bond. Okay, so due to that reason only, haloarenes are less reactive towards to the nucleophilic substitution reaction. And one more reason. Okay, so now first I'll complete the nucleophilic substitution reaction here. So then when the haloarenes are they involved in a nucleophilic substitution reaction means, so generally haloarenes are less reactive towards to the nucleophilic substitution reaction. But number of electron withdrawing groups are increases on the benzene ring. Number of electron withdrawing groups are increases on the benzene ring. The reactivity of the nucleophilic substitution reaction also is going to be increases. So what is the condition means here? Haloarenes are, note one. Okay, so note here. So haloarenes are less reactive towards to nucleophilic substitution reaction. Okay, but number of electron withdrawing groups are increases. 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 Okay. Reactivity is increases. Reactivity is increases. So one question they asked based on this concept, one question they asked here. So what is the question they asked me here? 1-chloro nitrobenzene, and another one is here dinitrochlorobenzene, and trinitrochlorobenzene, and NO2 here also NO2. Now, so which one is more reactive towards to the nucleophilic substitution reaction here out of these three? So
The
which
third.
Third one. So how you are telling that third one is the more reactive than the first two thought nucleophilicity is going to be increases. Okay, that means living group chlorine is easily cleaves here. Sir, how you are telling that chlorine is easily removes means because of number of electron withdrawing groups are increases. The reactivity also is going to be increases. Okay. Now which one is reacts more with the sodium hydroxide means trinitrochlorobenzene is more reactive towards the nucleophilic substitution reaction. Now you got the clarity? Is anyone having doubt? So no one you having doubt now? Okay.
No, sir.
Right one. So next, what is another important means here? Generally, haloarenes are it undergoes to the electrophilic substitution reaction. So generally, haloarenes are undergoes nucleophilic substitution. Sorry, electrophilic substitution reaction. Electrophilic substitution reaction. Substitution reaction. Okay, so generally haloarenes are it undergoes to the electrophilic substitution reaction. So what is the electrophilic substitution reaction? Do you have any idea? What is the electrophilic substitution reaction, ma?
When an electrophile gets substituted in the compound.
Okay. Now in haloarenes, electrophile is going to be substituted at which positions? Can you guess?
Para position, para and ortho.
Para and ortho. Samita, how you are telling that electrophile is going to be substituted at para and ortho position only. Why not the meta position?
Sir, I think it has a tendency of electron withdrawing.
No, ma. So you see here resonance structures I wrote here. Okay. Now if you observe here, sir, 1,2 position is called as a ortho position. Is it right? Okay. So that means here. So this position is called as a ortho position. This position is called as a meta position. This position is called as a para position. Now, if you compare with the ortho and para positions, negative charge is present at ortho and para positions only. But if you take meta position, what is the charge present on the meta position? This also meta position is there. This also meta position is there. Okay. So meta position is having positive charge. If the positive charge means again how you will add, how you will substitute the electrophile. Electrophile is nothing but positively charged ion only, na? Like charges they having the repulsions. Unlike charges are they having attractions. Okay. In the resonance structure, electron density is more at ortho and para positions. So due to that reason only, electrophilic substitution reaction will take place at ortho and para position only. Now you got the clarity? Now you got the clarity? Still anyone you are having doubt?
So it's more positive at meta position.
Yes, ma'am. Meta position means electrophile also having positive charge only, na? Positive, they're having attraction or repulsion.
Repulsion.
If it is having repulsion means how you're going to be substituted the electrophile on meta position, ma? Is any possibility is there?
No, sir.
No, ma. So that's why meta position we cannot take as electrophilic substitution reaction. Okay, electrophilic substitution reaction will takes place at ortho and para positions only. Now you got the clarity. Still anyone you having doubt until this point here? Okay. Now sometimes they're asking question. So which one is the major product and which one is the minor product? Also they're asking. So which one is the major product and which one is minor product? Also they're asking. Okay. Now shall we try some of the electrophilic substitution reaction? So one reactant only I can take here. So one reactant only. Okay. So what is the reactant I'm taking means here? Chlorobenzene I'm taking here. Chlorobenzene. If the chlorobenzene so I'm taking as a chlorobenzene. First of all, if the chlorobenzene is treated with chlorine in presence of AlCl3, okay, so because of we have to take as a catalyst, we have to take as a catalyst. In this one, AlCl3 act as a catalyst. So when you take as a chlorination in presence of catalyst means it forms as a 1,2 dichlorobenzene. So one product it forms as a 1,2 dichlorobenzene. Another product it forms as here 1,4 dichlorobenzene. We have two possibilities. Okay, so chlorine is going to be substituted at ortho position. At the same time, chlorine is going to be substituted at para position. So if you compare with the ortho and para, so which one is the major product and which one is the minor product means para substitution one is it becomes as a major product and ortho one it becomes as a minor product. Okay, so ortho one, this one is the para one is the major product and ortho one is it becomes as a minor product. Sir, how you are telling that ortho one it becomes as a minor product means because of in para one it has a symmetrical arrangement. It has a symmetrical arrangement. There is no steric hindrance it will be there. Is there any steric hindrance it will be there? When two bulky groups are present at same side means they have a steric hindrance. First of all, what is meant by the steric hindrance? What is mean by the steric hindrance? What is mean by the steric hindrance? Anyone of you having doubt? What is mean by the steric hindrance?
Someone can explain it. I wasn't there in the last class.
Okay. What is meant by the steric hindrance? So steric hindrance means one thing I can give my here clarity here. So actually in your colleges, how many members used to sit in one bench? How many members used to sit in one bench? Generally, comfortably.
2 or 3, sir.
2 or 3. Okay. Next, Aditi.
2 or 3, but
Okay. So 3 members comfortably we can sit here. Okay. So 3 members, let us consider it as a 3 members comfortably we can sit in a one desk. Okay. If 4 members, if you sit means how you feel? If you feel comfortable or you can feel as uncomfortable?
Congested, sir.
Congested you are feeling. Why you are feeling as a congested? Because of there is no space now. Because of it is sitting capacity depends upon the space only. Okay, in that 3 members desk only, if full fat persons are there, generally we can call as a sumos. Do you have any idea about the sumos? Have you listened the name of sumos?
yeah, sir.
Okay, so they are very fat persons are with that. Okay, if sumos are means how many members they can sit in the one desk?
1.
One only they can sit. If any possibility is there to sit 3 members in a one desk, is any possibility is there, ma? They can't sit, ma. They can't sit 3 members in a one desk here. So because of it is depends upon the size. If the size of the atom also is going to be increases, bulky size groups are, if it is, they cannot be placed at one side. Okay, these bulky groups are, they cannot be placed at one side. Okay, to overcome that steric hindrance, that is what generally we can call as whatever the uncomfortability is there, that is only we can call as a steric hindrance. If 2 chlorine atoms are present at same side means on chlorine atom electron density it will be more. On chlorine atom electron density it will be more. Due to the presence of the more electron density, they have a strong repulsion. If they have a repulsion means they become as unstable. So when they become as a stable means if 2 chlorine atoms are they present exactly in opposite direction. Okay, the distance is more, they're not having the repulsion, they become as a more stable. When they become as a more stable means that only we can call as here. Okay, then only we can call as here major product. Okay, the atom which has a more stability that we can consider as a major product. Okay, the molecule which has a less stability that we can consider as a minor product. So para substituted products are we can consider as a major products and ortho 1R we can consider as a minor products. Now we got the clarity. Still anyone you having doubt?
No, sir, got it.
Okay. Now,
Clear, sir.
so clear? So here, if it is treated with the methyl chloride, CH3Cl, in presence of AlCl3. Sir, my question is, in alkyl halide, so which one is the electrophile and which one is the nucleophile? That means in methyl chloride, so which one is the electrophile and which one is the nucleophile? In methyl chloride, which one is the electrophile and which one is the nucleophile? But do you have any idea about the Friedel-Crafts alkylation reaction mechanism? Electrophilic substitution reaction mechanism, do you have any idea or not? If you're not having idea means I can explain. Actually, in aromatic compounds, electrophilic substitution reactions takes place in 3 steps. Okay, so can I explain the mechanism?
Yes, sir.
Okay, right now. So now this is aromatic compound. I think so you're having problem with the electrophilic substitution reaction or mechanism with the electrophilic substitution reaction. So mechanism we can call here. So actually electrophilic substitution reactions are completed in 3 steps. How many steps it is going to be completed means here? It is going to be completed in 3 steps. Okay. So what are the 3 steps it is going to be completed? First one is generation of electrophile. Generation of electrophile. Generation of electrophile. Sir, how we are going to be generate the electrophile means if they had given any molecule, if they had given as a any molecule. In this one, we are taking as a AlCl3 is act as a catalyst. It act as a Lewis acids. I actually this draw. Okay, who's went ma? To Kathy's went okay. So in this one, so here generation of the electrophile. How we are going to generate the electrophile? For example, first reaction you can check it out by here. So we had taken as a chlorine molecule. Chlorine molecule. We had taken as a chlorine molecule. In chlorine molecule, how many atoms are there? 2 chlorine atoms are there. So if it is treated with AlCl3, it forms Cl plus and AlCl4 minus is going to be formed. It forms as a AlCl4. In this one, positively charged ion is called as the electrophile. In chlorine molecule, what is the electrophile means? Cl plus is the electrophile. Okay. And for example, now we are taking as a CH3Cl it is there. CH3Cl also it is treated with the AlCl3 only. Na? It is actually Lewis acid. Okay. Now it is also is going to be formed as a CH3 plus AlCl4 minus. It is also formed as here AlCl4 minus. Okay. And acyl chloride, that means CH3 bond, C double bond O Cl plus AlCl3 it is there. In this one, what is the electrophile? Acetyl group. That means CH3 bond, C double bond O plus. This group is called as an acetyl group. Acetyl group plus AlCl4 minus. Acetyl group is the electrophile. Okay. Now we are plotting as a nitration mixture. So what is mean the nitration mixture? Nitration mixture. What is meant by the nitration mixture? What is meant by the nitration mixture? So I actually also left out. Slowly, one by one, they are living here. I don't know what happened. So what is meant by the nitration mixture? Any one of you? Make it fast. What is meant by the nitration mixture? So nitration mixture is nothing but it is the mixture of concentrated nitric acid, HNO3, and concentrated sulfuric acid. Concentrated sulfuric acid is called as a nitration mixture. So what is meant the nitration mixture means? It is the mixture of concentrated nitric acid and mixture concentrated sulfuric acid is called as a nitration mixture. The last time in NEET they asked one question. In nitration mixture, which one is it act as an acid and which one it act as a base? That is the previous question. Previous year question. In nitration mixture, so which one is it act as an acid and which one it act as a base? Now in this one I'll give the clarity now. Okay. So sulfuric acid is it act as an acid and HNO3 it act as a base. Sir, how you are telling that nitric acid act as a base means here in this one, what is the electrophile means? NO2 plus is the electrophile and OH minus is the nucleophile. Okay, NO2 plus is the electrophile. That means the substance which releases the OH minus ions is called as a base. Now, the substance which releases the OH minus ions is called as a base. So that's why nitric acid it act as a base and sulfuric acid it act as a acid. Sir, what is the electrophile in this one means here? NO2 plus is the electrophile. Okay, and concentrated sulfuric acid. If the sulfuric acid is going to be ionized, so what is the electrophile in sulfuric acid? What is the electrophile in sulfuric acid?
Is it H2, sir?
No, ma. SO3H plus is the electrophile and OH minus is the nucleophile. So all these are the different electrophiles. All these are the different electrophile. So this step only we can call as a generation of electrophile. Okay. After generating the electrophile, what is the second step? Mean substitution of the electrophile on the benzene ring. Okay. Substitution of electrophile. Substitution of electrophile on benzene. Okay, so how we can going to be substituted on the benzene ring is now only we had seen as a resonance structure. If you know the resonance structure, so wherever the negative charge it is there, so that part is going to be attaches with the electrophile. So to make it clarity, how we can write means here, now we got as a like this structure. Okay, here double bond is there, here double bond, here chlorine is there. Okay, so when the pi electrons are shifted, here hydrogen is there, here we are getting as a negative charge. This negatively charged is attaches with the E plus. E plus is nothing but electrophile. You can take any one of the electrophile. Okay, now this carbon is having the positive charge. After attaching of the electrophiles, in a benzene ring, you will get as a positive charge. You will get as a positive charge. So this positive charge is delocalized on all the carbon atoms. When the positive charge is delocalized on all the carbon atoms means it forms as a sigma complex. It forms as here sigma complex. That sigma complex we can represent like this here. Here Cl bond H bond E. Either the sigma complex is highly unstable. Sigma complex is highly unstable. To become as a stable, immediately it undergoes to the elimination reaction. Which elimination reaction? It undergoes the deprotonation. If we remove the proton means again the double bond is formed in between the positively charged carbon atom and negatively charged carbon atom. Hence, what is the last step means here? Deprotonation step. Deprotonation reaction. So what is mean by the deprotonation? Means removal of the proton. So from the sigma complex, here chlorine is there, here proton is there, here electrophile is there. So it is the positive charge. Okay, if you remove the H plus ion, means, so this carbon get as a negative charge and the double bond is formed in between positively charged carbon atom and negatively charged carbon atom. So finally you'll get as a electrophile is going to be substituted either ortho position or para position. Sir, then what about this H plus mean? So H plus ion this reacts with again. So one more is there na? This H plus is reacts with here AlCl4 minus. Okay, but it reacts with the AlCl4 with byproducts or it forms as HCl plus again AlCl3. Whatever the AlCl3 it is formed, again that it is involves in a further step reaction. Okay, actually this is a reaction mechanism where you studied about this one means here in 11th standard we have a benzene aromatic compounds is there, hydrocarbons under the hydrocarbons is there or not? There we studied about the mechanism, electrophilic substitution reactions. Okay, according to that one we can write as the remaining structures also. Based on this one we can write as all electrophilic substitution reactions. So let's see what we are taking as here.
Sir, could you explain deprotonation again?
Deprotonation ma?
Yes, sir.
Samhita, first what happens Samhita here? So here we got as a sigma complex. Is that clear?
Yes, sir. Double
Okay.
bond is gone.
So sigma complex is having positive charge or negative charge ma? Sigma
Positive
complex is having positive charge or negative charge?
Positive charge.
Positive charge. Okay. So charged species, cations are highly reactive or less reactive?
Highly reactive, sir.
If it is highly reactive, means they are the unstable only na?
Yes, sir.
To becoming as a stable compulsory, they has to lose one atom na? So which atom they are losing means H plus. They are losing as a H plus to become as a stable. If it comes H plus means this carbon get as a negative charge or not? How the hydrogen it comes outside in the form of H plus means it donates the 2 electrons. It donates the 2 electrons to this carbon atom. That time this carbon get as a negative charge and it comes outside in the form of H plus. Okay, and then the bond is formed between the positively charged carbon atom and negatively charged carbon atom. Okay, and what are the H plus it is there? That it is combined with the AlCl4 minus and it forms as a H plus and Al3. Now we got the clarity?
The electrophile gets substituted instead of the H.
Ma, H?
H gets removed, electrophile gets substituted.
Already we substituted the electrophile. Second step only we substituted the electrophile by shifting of the pi electrons. But this step, second step, do you understand? Actually, here, in between this carbon atom, we have a double bond. Right?
Yes, sir.
When these pi electrons are shifted on this carbon get as a negative charge. And this carbon getting as a positive charge. Why you're getting as a positive charge means donates the electrons here. Okay. And wherever the negative charge is there, that negatively charged part is attaches with the E plus. Okay. Understand this step is you can understand this one.
Yes, sir.
Now you got the clarity?
Yes, sir.
Then okay. So remaining reactions, can you write? Can I write some this one? All of you, can you write the products for that one? All of you? All are the electrophilic substitution reactions only I'm giving. Okay. Now, when the chlorobenzene is reacts with concentrated nitric acid, HNO3 or nitration mixture, what is the product it is going to be formed? And sulfuric acid, H2SO4. Okay. So next one, it is reacts with Nalagani. Okay, it is reacts with CH3Cl in presence of AlCl3 and CH3C double bond O Cl in presence of AlCl3. Okay, so better to write the products for all these reactions. Let us see how many members you are going to be writing. We will check it out in tomorrow. Okay.
Yes, sir.
So until here you have a test for the Sunday. Okay, ma?
Yes, sir.
Right now. So we'll continue tomorrow. Thank you all.
Thank you, sir.
Thank
Send the notes.
Welcome, ma.